Today, we will demonstrate how Power over Ethernet (PoE) works and why it is necessary for devices like IP phones and wireless access points. We will first connect these devices to a normal network switch and observe that they do not power on. Then, we will see how they function when connected to a Cisco PoE switch and a PoE power injector. As you can see, there is an access point fixed on the ceiling. These types of access points are placed in large numbers, around 20 to 25 per floor. Providing power to each access point using an adapter, similar to home routers, is very difficult to manage. Running separate power and data lines on the ceiling can be quite challenging. To simplify this, Power over Ethernet comes into the picture. A 24-port PoE switch is a network switch that has 24 Ethernet ports with Power over Ethernet support. It can transmit both data and electrical power over the same Ethernet cables to PoE-enabled devices like wireless access points, VoIP phones. PoE standard supports different power levels, likely 250 watts, 370 watts, or 500 watts determines how many devices can be powered. For example, a 24-port Power over Ethernet switch of 370 watts can power 10 IP cameras, 6 VoIP phones, and 8 wireless access points. PoE Injector is a device that adds power to an Ethernet cable for non-PoE network switches. It typically has 2 ports. 1. Data in which connects to the non-PoE switch. 2. Data plus PoE out connects to the PoE-enabled device, supplying both power and data. This setup allows non-PoE switches to support PoE devices without requiring a full PoE switch. Let's try connecting devices to a normal switch. Connecting the IP phone to a normal switch. We have an IP phone, which requires both network connectivity and power to operate. Let's connect it to a regular switch using a standard Ethernet cable. As you can see, the phone does not power on because it is not receiving power from the switch. Connecting the Cisco access point to a normal switch. Let's try the same with a Cisco wireless access point. We connect it to the normal switch. There's no power, and the access point does not turn on. This proves that PoE-dependent devices need power to function. Let's try connecting devices a 24-port Cisco PoE switch. Connecting the IP phone to a PoE switch. As you can see, the phone powers on immediately. This is because the PoE switch provides both data and power over the same cable. Connecting the Cisco access point to a PoE switch. Similarly, the access point also powers up instantly. This makes a PoE switch a great solution for powering multiple devices without additional adapters. Let's try connecting devices to PoE Injector. Connecting the IP phone using a PoE Injector. Let's connect our normal switch to the data in port of the PoE Injector, the data plus power out port of the injector to the IP phone. The phone powers on, proving that a PoE Injector can deliver both data and power, just like a PoE switch. Let's repeat the same process for the wireless access point. The access point also powers up. PoE injectors are a cost-effective alternative to PoE switches when dealing with only a few devices. To summarize, while a 24-port PoE switch is very convenient, it can be expensive if you only need to power 1 or 2 devices. Instead of investing in a large switch, we can use a PoE power injector, which is a much more affordable solution.